Hello, tensor friends. When I was first studying tensors uh, and trying to understand the syntax, the index, the structure of these, it's tricky. Uh, the first thing you get introduced to that you're trying to understand is the outer, the product, or the tensor, the product. They call it both. And sometimes you'll see it written like this, and sometimes you'll see it without anything in the middle. And what they're saying is that the outer product of a two indexed tensor with a one indexed tensor will give you a three indexed tensor. And you see here by the rules that I have three free indexes, I, J, K. So nothing is repeated. So when you see this, you know it's going to be an outer, the product, and it's going to give you a three indexed tensor, right? So in three dimensions example, you've got 2 plus 1 here is going to give you 3, and this is going to be 2 to the third plus 1 to the third is going to give you 3 to the third components of each one of these things. A real easy way to understand that is look at this example. So this is just a one index the tensor outer product with a one index the tensor, but you notice that there's two free indexes here. So I'm going to wind up with excuse me, a two index the tensor. Well, we've actually all done this in linear algebra. I don't think that we knew what we were doing, but it was this. So we have the components of a column vector multiplied with the components of a row vector is going to give you a 2 by 2, the matrix, which is the components of this are a 2 by 2 matrix. That's what it looks like. Okay? In two dimensions. I must add, this is in two dimensions. In three dimensions, this will be a 3 by 3. All right? Then they hit you with this thing, tensor contraction. And they write it down like this maybe. A one index tensor multiplied by a two index tensor where you see these two indexes are the same is going to give you a one index tensor, and these are contracted out. A real easy way for me to understand what does that mean is to use the Kronecker delta. And you've seen this before. So the delta ij is equal to 1 if I equals j. Else it's 0. So if I does not equal j, it's 0. Okay? Let's use this guy right in this same thing. Let's just replace s with the delta. Okay, so ti multiplied by delta ji is equal to what if j equal 1? Let's I'll make up that j equals 1. Okay? Well, this is a summation index that we're all used to seeing, right? So this is the free index I have, so it has to be the same in every expression. So now we're in three dimensions. But this, since it's a summation index, is in the first case going to be 1, the second case is going to be 2, the second case is going to be 3. Well, what are these guys equal to? What is this and this and this? Well, it's these rules right here, right? So this one, 1's equal to 1 because they're equal. Here they're unequal, 0, unequal, 0. So that means that Ti delta 1i is just equal to T1. So thus, Ti delta Ji is equal to Tj. So that's a real easy way for me to understand what that means. What does that mean is being contracted? Well, it means this. Okay? Wasn't that fun? I'll see you later.